Lesson 1.6, we're going to take a closer look at these SI measurements. So our first objective for the lesson is for you to explain the difference between mass and weight.
Second one is to identify SI units for various quantities.
And then we want you to define the term derived unit.
And of course, describe absolute zero, and your reading for this one is 2.3, starting on page 30. So the SI, we talked about it briefly in the last video, but it's from the French, excuse my French, is Le Système International du Unitas, whatever that wants to be.
I think that must be perfect.
It must be perfect. My dad was a French teacher, but
Okay.
it hasn't rubbed off. Meaning the International System of Units, if you couldn't actually get that from the French. And this is known as your metric system. And these units are all based on physical standards. So each of these is described by a stable properties of the universe except for mass. So these measurements can never be lost, which is smart. So let's go on to these.
We'll take a look at each one of them individually. All right, mass. So you probably know this already, but we'll cover it again. Mass is a measurement of the amount of matter in an object. Now, a lot of times we will say, oh, go over to the balance and weigh that. But technically, that's not correct. Mass and weight aren't the same thing. Weight depends on the pull of gravity. So it depends on not only the mass of the object, but also the mass of the planet or planetary body that you're on and how close you are to the center of it. So the weight, bottom line is weight can change for something, but mass is a constant as long as you don't remove or add any matter to the object. Yeah. So when you measure mass, you're really measuring the amount of matter in something. Mass will not change due to gravity. Looking at the bottom of the page, you can see inside of these bell jars, that is actually the only metric measurement that's defined as by a chunk of something anymore, and not by some
random standard.
Definable standard. There's a chunk of platinum metal locked in a vault someplace in Paris, France. That is the standard kilogram. So all other kilograms are patterned after the amount of matter in that thing, so they keep it, inside a stable environment, so no extra weight gets picked up or lost, I guess, over time.
Okay.
But that's the definition of mass, and make sure specifically you remember the difference between mass and weight.
Yep. So the next measure is length. It's the measure of anything from end to end. The standard meter is defined by the length of path of light in a vacuum during a time interval of that number over a second. So that is a physical standard, but it was originally defined by a piece of, platinum iridium alloy encased in some airtight thing. But this one is now defined physically, and we cannot lose it. So
yeah, they were worried that somebody blew up the standard meter, then we wouldn't know how long a meter was, exactly, or it got destroyed or lost. But now defining it in this way, we can never forget how long. You could always recreate that length. Okay, so the third metric or SI unit we're going to discuss is the quantity of volume, which is the amount of space an object takes up. In the SI, volume is a derived unit. What we mean by a derived unit is that it's defined in terms of one of the other units. And the base unit of volume is actually defined in terms of length. So 1 liter, that's our base volume unit, is defined as 1/1000th of a cubic meter. So if you look at the photograph we've included there, this is a liter cube. Now you don't have to have something cubic. You can have any shape that be a liter, but if we wanted to define it cubically, we would measure out a plastic box, and you can see this box is 10 centimeters long, and if you measured it from the back to the front, it would be 10 centimeters on that dimension, and top to bottom it would be 10 centimeters on that dimension. That's the definition of a liter. So it's defined in terms of a cube with particular measurements. That means it's derived. So volume is derived from length,
which is then derived from the path length of light. All right, so temperature is our next scale, and that's defined as the average kinetic energy of the particles making up a material. That's an important thing to remember.
Wait a minute, I thought temperature was how hot something is, Mr. Hunter.
That's what we're going to get to. Heat and temperature are two different things. As we said, temperature is the average kinetic energy of a particle. It's how fast it's moving and how often it makes collisions. But for heat, Heat depends on the amount of something. So this is kind of odd to think about. We use these terms kind of interchangeably. Well, it's a hot day. What's the temperature out? So think of it like this. We have a bathtub that's at 50 degrees Celsius, which is nice and warm, but not too hot. Has more heat, but less temperature than a beaker of boiling water. A beaker of boiling water has anywhere between 100 milliliters to 1,000 milliliters, where a bathtub has, 50 gallons in it maybe. So the bathtub,
100 liters,
yeah, the bathtub has a lot more heat energy. It's describing the amount of energy in something, whereas temperature is describing the average kinetic energy of those particles.
So if you only have a few particles,
Yeah, very little energy total.
all right. So now, when we measure temperature, we use two common scales in science, Celsius being the one that you're probably already familiar with. This would be used for your everyday temperature measurements, and all of our thermometers in our chemistry labs are Celsius thermometers. So the way a temperature scale is set up is generally you pick 2 points and you decide what temperatures they're going to be. So the Celsius scale is based where it's 0 point, the 0 degree Celsius point is the freezing point of water. And then they set the 100 degree point as the boiling point of water at sea level. So Celsius is based around water. Now the other temperature scale that we will encounter in chemistry and sometimes in physics is the Kelvin scale. So the Kelvin scale is what we would call an absolute scale. So it's based on the Celsius scale. In other words, its increments are the same size. If you go up 1 Kelvin, you go up 1 degree Celsius. But the difference is the 0 point. The Kelvin scale begins at absolute 0, which is the lack of all molecular motion, which is the coldest possible temperature you could ever have. So when we need to use temperature mathematically as part of a calculation,
You tend to use Kelvin.
we need to use Kelvin because of the fact that it's an absolute scale. So 0 actually means 0 on the Kelvin scale, where 0 Celsius is just sort of an arbitrary point because of where they selected, because water, the freezing point of water is, but 0 Celsius is not the coldest possible temperature. So for that reason, and we'll show you how to convert back and forth between them later in the year. But just for now, if you just know how they're defined and kind of how they're alike and different, you're good.
And keep an idea of what absolute 0 is. That is the lack of molecular motion. That's a very important concept to understand. So here are two thermometers, one that measures in Kelvin, one that measures in Celsius. And you take a look, you can see that these points are all, I guess, for every 1 Celsius, that's 1 Kelvin. That's a nice thing to know. So the first point what you look at, of course, would be, let's say, the boiling point of water. And in Celsius, that was set at 100 degrees, just arbitrarily. So in Kelvin, that would have to be also arbitrarily set. But now it is 373 Kelvin. So the next one, the water freezes at 0. That was the set point that they chose, which would be 273 Kelvin. And then if you want to notice, they're each 273 apart, so you might figure out how to convert between Celsius and Kelvin right now. But lastly, absolute 0, obviously, that would be negative 273 Celsius, and 0 Kelvin. As we said, absolute 0 would be 0, where all molecular motion ceases.
So I think we would like you to copy this into your notes, but I don't think you need to add any of the temperatures except the ones that I've circled. And notice also that when we record the measurements, the unit of Celsius has the little degree symbol, but on Kelvin it's just a K.
Yep.
Go ahead.
So here are the measuring tools that we're going to see commonly throughout the year. Right here is something for measuring volume. That's a graduated cylinder. To the far right, you see a giant grouping of thermometers. Those are for measuring the average kinetic energy of the solutions that we're going to be looking at, also known as temperature.
Okay, sitting on top of the balance is a ruler, which we can use to measure the length of something. And then the balance itself, that's this whole instrument right here, that would be our base tool for measuring masses.
What is it currently telling us?
So we have 19.09 grams of ruler sitting on the balance.
All right, we'll be becoming very familiar with how to read these properly and their uses.
Take care of them and
Yep, how to use them basically.
Right. All right, so here's your post-video questions. They're self-explanatory. I won't read them for you, but I would pause this and see if you can use the notes you just took to answer these 3 questions. Good luck.
Have a good night.